radiation. So every time we think of radiation, we think of something bad, but it doesn't necessarily have to mean something bad. Radiation can also be used for something, for medical purposes, such as radiation therapy. And radiation therapy can be used to kill cancer cells. So there are two types of radiation, one that is ionizing and the other one that is non-ionizing. So ionizing radiation is when an atom becomes ionized, meaning that an electron has been removed from the outer shell. So radiation has the capacity of transferring energy from one object to the other. So everything at this moment surrounding us is made of atoms. Atoms are made of a nucleus that contains protons and neutrons inside of it and surrounded by electrons. As we can see in this scale, electromagnetic radiation is broken down into categories of ionizing and non-ionizing radiation, based on whether it has enough energy to knock electrons off the atom that it interacts with, as well as being able to do lower energy damage, such as breaking chemical bonds in molecules. Ionizing radiation, which is caused by unstable atoms giving off energy to reach a more stable state, is more of a health threat to humans since it involves changing the DNA molecules inside the cells. Alpha, beta, and gamma, which have different properties, therefore different effects on biological tissue. Alpha radiation consists of high energy helium nuclei. The range of the alpha in the air is only a few centimeters, and in water is even lower. A paper will be enough to shield from this radiation. In the situation where you will be only influenced externally, the alpha particles will only penetrate the outer skin layer, and it will not reach deep of more sensitive tissue or internal organs. Alpha radiation could, however, get into the body. If they are inhaled, then the alpha radiation could emit their potential into the organs. The beta radiation consists of electrons and positrons, which compared to the alpha particles have a much lower mass. Therefore, the range in the air of beta is a few meters that can also penetrate deeper into the skin and emit their energy there. Also, through ingestion of beta emitted into the body could lead into circumstances of severe radiation exposure. Beta can be shielded by a few centimeters of aluminum. The gamma radiation photons penetrate easily and ionize the surrounding atoms as it passes through matter. So gamma rays are the most dangerous because these type of rays can travel through any material. So basically, the only material that gamma rays can be stopped is lead. And it has to be several layers of it so it can actually stop it. For this one, I would like to mention as well that infrared radiation is the one that is not visible to the human eye. So this is not visible to human eye. And this one is. The visible radiation is visible to the human eye and is the one that converts plants which is the one that plants convert into food, as I have mentioned before. Cut! So far, I have mentioned that radiation is energetic waves or particles But there are other forms of radiation that are actually particles with mass, such as alpha, which has 2 protons and 2 neutrons and a nucleus of helium or helium, I apologize, and is represented by the letter A. We have beta, which is represented by the letter B, and we have gamma, which is represented by the letter Y. With a charge of 0, because it is an electromagnetic wave and it has no charge, the beta, it has a -1 charge, and the alpha has a +2 charge. Cut.
Hello everyone, today I will be talking to you about ionizing radiation and some of its units. The following units are for radiographers to keep in mind throughout their career. In ionizing radiation, some units come simply from exposure of air. In the international system, this is composed as rogaton, and its units are coulomb per kilogram of air. Another ionizing radiation is radiation absorbed dose, which basically measures the amount of radiation that any patients or any objects can absorb in the international system. The radiation absorbed dose is measured within the units of Gray. As for radiographers who work in occupational exposure, we can also be exposed to what is called radiation equivalent in men. In the international system, the measurement is sievert. In nuclear medicine, to measure the radioactivity of radioisotopes, it is known to use the dose measured in Curie. The accreditation goes to Curie and Becquerel for these particular units of radiation. Activity is measured by Becquerel, where 1 Becquerel equals 1 decade per second. Radiation releases energy when it hits a human being. Absorbed dose is the amount of energy released into the human being per kilogram of body tissue and is measured in a unit of Gray. 1 Gray equals 1 joule per kilogram. However, absorbed dose is not a clear measure of the harmfulness of radiation because the various types of radiation affect tissue in different
in the units
ways.
Of sievert, as 1 sievert represents a large amount of absorbed dose. It is more common to speak in terms of millisieverts. The scale of radiation dose is one with a wide range. If we say that a lethal dose is 5,000 millisievert, the average sievert is exposed to a yearly radiation dose of a few centimeters, and the radiation that we are subjective will correspond to 100 centimeters. The lowest doses of radiation of induced cancer corresponds to 50 millisievert.
As I previously mentioned, this is the track to determine how bad or how much radiation may produce damage. We need to take into consideration that ionizing radiation is damage, even though a small amount can produce some biological correspondence. The typical dose limit applied to radiation works in the public, and the material is biologically natured. It is not the temperature raised that is of concern. Under these circumstances, the concern is the cellular and genetic damage can lead to an increased risk of early death, primarily through an increased likelihood of future cancer development or increased likelihood of childbirth defects or inherited conditions. These effects are not only dependent upon the energy deposited by the radiation, but also by the type of radiation deposited in the energy. Now I will continue with briefly discussing about the dose limit and the NCRP report. In 1964, the Congress charted the NCRP, which stands for the National Council on Radiation Protection and Measurement. The NCRP is a nonprofit organization that is charged with collecting, analyzing, and developing information and recommendations about radiation protection, radiation measurements, quantities, and units. In the NCRP report number 116, the term of equivalent dose is represented as the letter H in defining those limits. Additionally, the recommended dose limit has been established as 1/10 of the effective dose limit for radiation workers. These are the ionizing radiation units within the international system. I hope you all enjoyed this video and have more of an understanding towards radiation exposure. Thank you for your time, and I hope you all enjoyed learning about ionizing radiation. Until next time!